Yo, what's up, everyone? We're back at it with week two, and I definitely apologize for things coming in kind of slow recently. I definitely have been pretty sluggish myself, but we have really done well this quarter already with the tests, so I'm not really that worried if we miss that one problem set. But yeah, we're going to tackle probability for the next 3 days, and then after that, we'll take a quiz like next Thursday, a week from today, and then we'll call it quits before Thanksgiving break. And I'm personally really relieved that that break is coming up. I feel like life has been coming at us really fast recently. But, the good news is the vaccine is looking really good. So I feel like we're going to see each other sooner than we think. And now it's just kind of the time to grind on the things you need to do for now. Figure out what you want to do before this is all over, because you're not going to have like unlimited free time for the rest of your life. Like, I've personally really found this as a nice reset because life is nuts. So yeah, I'm not saying we're going to go back really soon. I wouldn't bet on bet on anything like sooner than March, but still, like, time's going by quickly. Figure out like what are your priorities going to be for now. And I'm not judging you if it's just play video games all the time, but like think like you have this time. What are you gonna use it for? But anyway, we're starting probability, and what's really interesting here is that the course kind of takes like a curve, where everything we've done so far has been really like a logical flow. We're just talking about data, which is what you think of when you hear the word statistics anyway. But there is a second component to statistics, AP statistics, which is probability. And the cool part about it is that it will all tie back to data sets eventually. Okay? And kind of the mix of what we did in the beginning of the year and probability is like what the very end of the course is all about. But before we get there, we just completely shift gears. And this problem set's going to kind of look different than everything we've done so far, and that's, totally fine and honestly probably a good thing, probably interesting. But we're just going to start with logic, and then we're going to see how we can turn what you already kind of assume probability is into actually a table, into something that we know how to do, or something that's going to kind of make more sense. Okay, and we'll start with the first question. It says, imagine rolling a six-sided die. Without overthinking it, what is the probability that you roll a six? And very quickly, like, a probability is a percent, or like how likely a certain outcome is. Okay? So we're going to start thinking about things that occur, and we're going to call them events. And the event here is that you're rolling a die. And we know that when you roll a die, there are certain outcomes, right? You can get a 1, a 2, a 3, a 4, a 5, or a 6. So the probability is always going to be the probability of the specific outcome you're looking for, in this case rolling a 6, compared to all possible outcomes. And in this case, there's 6 outcomes, right? And we know that everything in a die has the same probability, and I didn't bring something up, but you roll a die, a 1 through 6 die, and it's going to give you anything from 1 to 6. These ads are hilarious. Mushroom supplements. But yeah, there's 6 possibilities. So you know that if you wanted to find this probability, which is going to be percent, before this class you probably would have known that it's 1 out of 6. But, I didn't really explain anything there. So I really want us to visualize what probability is. And the first thing that we're going to do to visualize that is, while we don't have graphs in this unit, we're going to start creating a lot of diagrams, okay? And the first diagram that we're going to create is basically what's called the sample space, which is all possible outcomes. And the really good news about probability is it is conceptually difficult, but the math itself is really easy. So you shouldn't really have trouble with this packet. It's going to be easier than correlation stuff. Sample drive. So we're going to start using like a box to represent all the possible outcomes. But before we do that, we're going to just create a table, just like we could have done in the beginning of the year, that represents all the outcomes, right? So instead of thinking that there's data that falls under a certain category, right? There's no data points here, but each of these outcomes has a 1 in 6 chance of occurring. So you could really create just a relative frequency table where we know every single die roll has a 1/6 chance of occurring. So it's not a two-way table or anything like that, because we're not talking about a data set. We're talking about an outcome that we don't know what's going to happen, an event. But these are the probabilities. And if we were going to draw that using a diagram of the sample space, all I want you to think is that we could split this box into sixths, where each sixth represents a die roll. Let's see how I do. I did really bad. But you can think that if you were to like kind of throw something onto this, this would represent the likelihood of rolling a die, right? Each outcome has an equal chance. And this, honestly looks kind of stupid right now, but we're going to come back to this and for the next example on why that's important. But for now, just think of the sample space as everything that's possible, right? So if you roll the die, these are the outcomes. And this box like physically represents how much space they occupy in the sample space. So 1/6 each. For C, it says what is the probability that you roll a 2 or higher. And the first probability rule that we're going to adjust very quickly the next lesson even is that when you see the word or, you can usually add, right? And because we're talking about a single roll, which is a single event, one time, we're rolling it one time, all we're going to do is add up those 5 possibilities, right? And if we're visualizing it, it'd be this area of my entire sample space, so 5/6. Okay, so we're not going to do any math other than to say it's 5/6. But that's because we can add up those 5 outcomes. And then finally, for D, it says what is the probability that you don't roll a 4? And we're going to do a little bit of notation here. If we're going to talk about the event being rolling a 4, let me write that. Something that we're going to do a lot is the opposite. Okay, and we want to have a word for that. So we know that you could roll a 4, but this is asking a probability that you don't roll a 4. So we call that the complement. Which is denoted as a C, and we'll get to that next time. But yeah, that's just kind of the first vocab word. In this case, if we know that the probability of an event, what do you think the opposite is going to be? So you don't have to do it this way because you could just count, oh, it's this and this. But sometimes it's easier to think, okay, the probability of rolling a 4 is 1/6. So the probability of not rolling a 4 is 1 minus that. Because think of 1, when you're talking about adding and subtracting fractions, as representing 100%. So anytime you need to find the probability of something not happening, think of it like this is like 16%. So we want to do 100% minus 16%, right? And you can barely read that, but that's the logic. 1 is the same thing as 100%. So in this case, it's like 84%. Okay, so that was example 1. I don't think that should be too bad. So far, very straightforward. But this is where it gets complicated, but cool. And it says that we're now going to flip a coin and then roll a die. So we're going to do 2 different things. Okay? And whenever you have to do that, in this case we're talking about a single example, the really short answer is you're going to multiply the probabilities together. Okay, so you might have been able or already known that, but we're going to kind of try to figure out why that is. But for A, it says, what is the probability that you flip heads and then roll a 1? So we have 2 different things going on here. And whenever you have 2 things going on, I like to write it out and think about them separately, right? Because in this case, whatever happens when you flip the coin isn't going to affect rolling the die, right? And we're going to call that independent. Like, we keep hearing the word independent, but those 2 events don't affect each other at all. So when we calculate the probabilities, we should do them separately, okay? But before we do that, we're going to do B at the same time. Let's talk about the sample space of everything going on here. Okay? So first, if we're talking about the single event of flipping heads, think that you're going to flip heads half the time, right? So one of these, like the top one, just like a coin, could represent heads, and the bottom could represent tails, right? They're equally likely. And we could even write that here. The probability of event 1 is 50%, or 1/2. Now, there is a second thing happening, and that's that we roll a 1. And we know from the first example that rolling a 1 is just 1/6, right? But if we were going to draw doing one of them and then the other, and I think this is really cool, maybe you already get it. Not only does it have to flip heads, but it has to be a roll of 1. So think that in this world where we rolled heads, 6 things could happen next, right? We could roll 1 through 6 on the die. And what is that probability going to be, right? We're going to multiply 1/2 to 1/6 to figure this out, because I want you to think that half the time you get heads, so only half of the outcomes are possible, and then within that half, it's 1/6. So it's 1/6 of 1/2, right? There's 12 things that could happen. You can get heads or tails, and then 1 through 6 with the die. And I don't even know if I'm saying this that well, but I think that even this diagram speaks for itself, right? For you to flip heads and for the die to roll 1, it's gonna be for you to flip heads and for the die to go 1. 2 things need to happen. The first thing only has a 1/2 chance, and the second thing has a 1/6 chance. So this is like 1/12, which is going to be like 0.7. No, 0.0833. So in this case, it makes a lot of sense. But that rule works always, even when the probabilities are a lot smaller, okay? So you don't always have to draw the sample space, but know that if you want 2 things to happen, this and then this, so the second big probability word is and, you're going to multiply those probabilities together. And we're going to come back to tree diagrams, and I'm going to skip it honestly right now. The video's taking a little longer than expected. Okay, so we have this third example, and we kind of have the logic down. I don't think I'm on my game 100%, but I think that's fine. And what this one says is that imagine you're using a random number generator and then rolling a 6-sided die. Now I'm gonna do some editing magic here, and I'm gonna put a random number generator over here. But what I want you to do is just Google random number generator while you watch the video, because you're gonna use it a lot for the probability unit. Okay, so the first one says if you set the random number generator to select the number 1 through 15, what is the probability you choose 7 and then select a number greater than or equal to 2 on the die? So the first thing to realize here is that we have two independent events, and we want to find the probability that they both happen. And if you see "and," you have to find two separate probabilities and then multiply them together. That's kind of the whole gist of today. So I like to write it as event 1 and event 2, and we want to calculate those probabilities. So when you're using the random number generator, you select a lower number and an upper number, and then it's really that straightforward. Okay, so if the random number generator is set 1 to 15, I want you to think that every separate number has a 1 in 15 chance of being selected. Okay, so if it's asking us the probability of choosing a 7, that's just going to be a 1 in 15 chance. If it's at a 7 and an 8, it'd be a 2 out of 15, etc., etc. So the hardest part of this is honestly going to be these individual probabilities, and for that you're just going to kind of have to be a little bit logical. For the second one is a probability that we select a number greater than or equal to 2 on the die. So it's 2, 3, 4, 5, and 6. And some of these, like, you're allowed to do it in your head, obviously. But if ever it helps, if it's asking you something that's kind of tricky, you can write out your outcomes and think what it means. Greater than or equal to 2 is just all of these, so 5 out of 6. So this probability is pretty easy to calculate. It's just 1/15 times 5 out of 6. And again, it's because of kind of the diagram splitting up a sample space. So this is 0.055, and you got to get used to looking at decimals and understanding what the percentage means. Okay, and we've already done this, but I think it's worth saying a few times. But we use the decimal more often in this class because we plug it into the equations. You never plug a percent into an equation. But if you see something in 0.055, you got to start thinking 5.5%. The rest of these should be really easy. It says random number generator 1 to 20. What is the probability you choose a prime number and then a number that isn't 1 or 2 on the die? So prime number is a little more tedious. It's saying the chance you chose a prime number, and you will include 1 in this class, okay? So I'm just going to list my prime numbers, which might take you more time, and that's cool. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a lot of numbers. So 45% chance that we choose a prime number, and then a number that's not 1 or 2. So it's going to be 4 out of 6 here. So I think you will have an easy time here. So that's 30%. This last one is almost silly now, but I'm going to skip it. Like the whole point, yeah, I'm going to skip it. Alright, that's the whole thing. I don't think it's my best, but that's okay. And we got 2 more worksheets before Thanksgiving and a quiz. Woo!